On this episode of 5 Minutes of Cloud, we're going to talk about Docker, and at least cover the basics of what Docker actually is. So if you're at all involved in cloud development or cloud services enablement today, I'm sure that you've heard of Docker. Docker is a very powerful tool and has simplified a lot of the management and application creation requirements that went along with using the container model for managing cloud compute resources. Containers have been around for quite a while, and we actually have some other episodes specifically talking about containers. But the Docker model, and specifically the Docker image file format, was one of the major steps in making it easier to use containers and actually make very lightweight containers possible for many application deployments. Now, in my view, containers really are an interesting way of bundling your application. You still need services on top of that to then manage the orchestration of multiple containers working together. And in the Docker space, that's actually handled by the Docker Compose functionality. So before I get too far ahead of myself, to actually create an image that Docker can then run, so Docker as runtime engine can run, we would use the Docker file format. And the Docker file is really a list of the resources that need to be implemented within the image that you would like to create, often building off of another image. So this is one of the other aspects of this Docker image format that make this tool so powerful. The Docker image format is a layered file format that basically gets collapsed into a runnable image through the Union file system model. But in doing that, I can take somebody else's initial Docker file effectively and build out a new baseline image, or I can just get a copy of their image and then extend it with an extended Docker file option. So by building these files out like this, and by building the images out like this, I can create the first step of having the image that the Docker engine can run. Now that image then needs to be shared, at least amongst my local resources, and I do that through the Docker Registry model. And I can have local registries, or I can use the public Docker Hub registry, or a couple of other equivalent image registries that exist out there to now manage and share, if appropriate, my baseline images or my modified images with my application environment in it. So that gets me the image, and then I can use tools like Docker Compose to actually manage deploying multiple containers and connecting them together to actually build out a service out of multiple containers. So this fits very well into the microservices space that people are talking about, where you've defined sort of an interaction internally between your application and its components, and then you would present to the rest of the world a single interface that is basically an API-based interface that allows you to communicate with this container. So Compose then enables that level of resource. Initially, Docker was very much single entity focused. So Docker containers still need to run on a physical server at some point. It could be a virtualized version of a physical server, but they do need to run on a server. But often one server isn't enough, especially for very large applications or for multi-service microservice environments. And for that, Docker enabled a tool that they called Swarm, which has now been actually incorporated into the core Docker engine. So when you deploy Docker today, if you have multiple systems that you're deploying onto, you effectively get this Swarm capability, which in conjunction with Docker Compose lets you define a multi-container, multi-system, super scale-out environment. Docker Swarm also includes, or the latest version of Docker, which incorporated the Swarm components, also includes load balancing functionality. So now my containers, as they start to scale out, maybe I have a web service in a container. As that scales out, I actually can load balance access into that container environment so that I can distribute the load across multiple compute entities. So this provides for an end-to-end, powerful, scalable systems environment. And from the application developer perspective, you can deal now with composing the application as a Docker file that then gets deployed into a registry, which then gets consumed by your composed and Docker Swarm environment for production. So again, if we talk about the end-to-end pieces, we start with the description of your container as a Docker file that potentially layers on top of others, that gets posted into the Docker Hub, for example, or your own local registry, that gets pulled into consumption with the Docker Compose functionality and is then run in a Docker Swarm environment that provides that scale-out capability within the actual compute infrastructure. Thanks for watching. If you haven't already, don't forget to subscribe to our YouTube channel. In addition, if you want to stay apprised of the latest ongoing updates in the cloud space, sign up for our Twitter feed and our mailing list. We also update you on upcoming webinars and classes that we provide.